Alright, let's look at the setup instructions on the ES756 family member ES756. Again, try to follow along in your user manual on page 6. You'll notice when you first attempt to enter the program manual, the unit may respond that it's currently locked. In order to unlock the unit to begin setup of the instrument, you need to press the lock button 3 times quickly until you get a prompt for code. By pressing enter, you can now begin entering your password, and I've used internally a password of 1,000 to lock the instrument. So I'm entering now my unlock code of 1,000, and you'll get a message saying that the unit is now unlocked. Now, the menu flow through these menus is such that after completing each group, it returns you to the operating mode, or run mode. I like to show the flow rate, so whenever I am back and I observe an R in the far left, I know I'm in the run mode. So let's begin the setup. By pressing the program button, it'll go into the menu labeled input. By hitting enter, it'll offer you a number of selections. At this point, the operation of the program button changes to one of selection. And in this case, we want to set it up to receive an input signal of 4 to 20 milliamps. So I'm going to press the program button until that display appears. You'll notice that it's offering me a variety of inputs. When I get to the one that I want, I press enter. At this point, it will ask me, is the input a linear signal, or is it one from an orifice plate or other square law device that needs to have a square root extraction done? And you'll notice I can change to tell it that the signal is either a linear signal or a square root is required. After I've made my selection, it returns to the run mode as indicated by the R in the far left. I can now go in and change some of the other menus in a similar fashion, one menu group at a time. So again, pressing the program button, I'll go to the next set of submenus, which are titled relays. I'm going to set these up to be rate alarms. So I will have selections here where I can determine how each of the relays is used. For the A relay, I have selections that it can be a rate alarm, be assigned to total, or to be a pulse output. Again, I want to use in this application my A relay as a rate alarm. So while that's displayed, I'll press enter. It now allows me to set a hysteresis for that A rate alarm. In this case, you'll notice that the hysteresis is set to 1. I can now move on to the setup of the B relay. I'm also going to set up the B relay to follow rate. Once again, it has the selectable uses of total, pulse, and rate. On this model, only one of the relays can be used as a pulse output. So I'm going to be using the B relay for rate also. Such might be the case if you have a low flow rate alarm and a high flow rate alarm that you're trying to have with your basic rate totalizer. Once again, there's a hysteresis that's available for it, and I'm going to set this one also so that the hysteresis has a value of 1. Okay, at this point, you're back to the run mode as indicated by the R in the far left-hand position. Let's go into the next menu. This menu group is called Lock. And in this menu, you can either have it just lock the program, which will prevent people from getting into the menu mode of the instrument, or you can change it to lock all, which will block people from changing the set points for the A and B relay. That's the mode we're going to require. You'll also notice that there's a place where you can change the code that's used to lock and unlock the unit. In this case, I've predefined my password code to be 1000. By pressing enter one more time, you'll notice it returns to the run mode. Now, the next menu group is where the actual span of the 4 to 20 milliamp will be set, as well as other variables. So I'm going to go into the menus until I get to this one menu group called Setup. Now you'll notice that there's a place for a decimal point location, and it's asking for the rate decimal location that's to be used in this application. And we have a position of 1 being shown. Now this is then used in the set high parameter, which is the full scale value of the 4 to 20 milliamps. And here I can set the flow rate to the maximum I expect for this flow meter. Now to set it to a maximum flow rate of 1000, I just have to toggle through the digits in the various locations until I see the desired full scale, then press enter. You'll notice that there's a low flow cutoff in this model at this next menu. So I can set this to a rate where anything lower than that value will be displayed as a 0. I'm going to set this to 10 gallons a minute so that any flow rate corresponding to the 4 to 20 input that's less than 10 gallons a minute, the unit will display a 0. Now, this next menu, normalization, is one where you can provide averaging of the input signal. If you put in a larger number, you can end up averaging over a number of readings. The actual algorithm that's used is shown in your user manual. The next menu lets you tell the time base of this 4 to 20 milliamp input. I've been setting this up for a flow rate that's 0 to 1000 gallons per minute, and this mnemonic representation is meant to be minutes. You'll notice that there are other selections of hours, days, seconds for your flow rate. We're going to be choosing the one for minutes. The next menu location is for the Totalizer decimal point location. And let's assume we want to read in whole gallons. I can set so that there's no decimal points, which means we'll have a display in whole gallons on the total. Now the next parameter is if you wish to display your rate and total in two different units of measure. For example, if you wanted to show flow rate in gallons per minute but total in cubic feet, you can use this conversion factor. In this application, we're not going to need that since we're showing in gallons per minute and display in gallons. So I will just be entering in a conversion factor of 1. There we go. We have our conversion factor of 1. The next measure is if we want to scale the Totalizer to read not directly in gallons, but some decimal multiple. And here I can choose from reading in whole gallon units, tens of gallon units, hundreds of gallon units, or thousands of gallon units. You can choose the multiplier that best suits your need to represent your total on the instrument. Now once again, as I complete each group, it returns to the run mode. Now there's one final menu group that we're going to set up now, and this is for the analog output settings. And this is in a menu group that's called Options. And here, I'm going to set the 4 to 20 milliamp retransmitted output also to 1,000 gallons a minute. And you'll notice that it's already set to that value. By hitting enter one more time, we are back to the run mode. Since I've completed my setup, I can lock the unit by pressing the lock button 3 times quickly, and at the prompt for the code I can put in 1000, which is my predefined password, and hit enter. You'll notice now the unit displayed that it's locked, as well as resumed displaying the flow rate. At this point we can tell that if we attempt to reset the total, it informs us that the unit is locked, and it will no longer allow us to reset the total. If you needed to reset the total, you'd have to unlock the unit temporarily in this situation. This completes a description of the basic setup of the ES756 INT69. The key elements to remember on this model is it offers you a variety of inputs for both linear and square law devices, as well as output uses including scaled pulse. Thank you very much, and we hope you enjoy this unit.